All right, so my name's Eovito. I'm a data scientist at IBM. I'm joined today by my wonderful co-host, William Roberts. He's a data scientist at IBM as well. And this will be broken down in kind of two phases. The first half is going to be setting up this problem of, what do data scientists face and where can automated and semi-automated machine learning fit into this routine, the routines data scientists perform. And then we'll be showing you the AutoAI tooling from IBM. That is what we'll be going into, as well as data refinery. So with that being said, Will, is there anything you'd like to go over before we kick things off?
No, all good. It's all yours.
Awesome. So we're going to use this PowerPoint really just to set up the problem and why we would use these toolings and paradigms in order to, increase the efficacy of our work. So where do data scientists spend their time? So I'm sure we've all heard the idea that data scientists spend a majority, anywhere from 70 to 90% of the time cleaning and curating and purging data. We're going to assume that we're beyond this point and that we're actually focused on modeling and, utilizing the data to perform some kind of prediction or classification of some sort. So with these assumptions being made, where data scientists spend a majority of their time are things such as feature engineering. This is in both the performance sense of, what features are going to actually contribute to a prediction or a classification, as well as, the statistical analyses of, do we have things like skewed data, multi-collinearity? Do we need to normalize? Do we need to, do some kind of transformation, things of that nature? So it's a combination of, know-how and experience, as well as subject matter expertise, depending on your data set, because, tabular financial data is going to look much different than the features associated with images. So that's where this expertise comes in. We also have the problem with algorithm selection. So not only knowing, what suite of algorithms works for classification and prediction problems, but, what are the nuances? What are the assumptions? So, the idea that, naive Bayes assumes linear independence versus, logistic regression. There's other underlying assumptions that we make in order for these to be effective models. And then the last one is, we've done feature engineering, we've done algorithm selection, we're, getting results that we can do experiments and compare and contrast against. Now we come to hyperparameter optimization. So, number of trees, minimum values for splits, what solver we're going to be using, things of that nature. And this all fits into the scheme of automated and semi-automated data science, where semi-automated data science removes some of the headaches associated with these time expenditures, and automated data science from AutoAI removes all of this, where we just go through the user interface, and a lot of this will be taken care of for us. We'll be going into that in more detail. I'll be showing you guys semi-automated data science with open source tool called Lawless. So a way we can think about these problems is that we can formulate them as a search problem, where we search some kind of solution space to find, the most likely, the most productive outcome. So I'm not going to read off all of these bullets. I'll give you guys the time to read through them. The ones that I do want to read off, so I make sure everyone does see them, is, the idea of, which features and data are best used for training models. That's something that everyone, across the stack is going to be, have to pay attention to. And then another one is, have any assumptions been introduce potential risk for the use case? So, are we making assumptions about underlying data distributions? Are we making assumptions that, features are ordinal versus being cardinal? So what are we introducing to the data and the models that is, extraneous in the sense it's not insular, it's not coming from the data, it's not coming from the actual model, because data scientists, do imbue some of their own insights into the work they perform. So I'll give maybe like 10 or 15 seconds for everyone to read through this before we go into the next slide. And if there are any questions, please feel free to drop them in the chat, and I'll get to them as soon as possible. All right, we will go to the next slide. So what is AutoML? Auto machine learning describes any tool that automates one or more parts of the intelligence workflow. So as I said, we'll be going through data refinery, which is the data portion, and then he'll also be going through AutoAI, which is our full stack solution. But other things are feature engineering, model selection, hyperparameter optimization, model validation, as well as deployment. And we'll go into more detail in the latter half of this session. So what can we actually do with AutoML? Build models faster. It helps us differentiate and find signal from noise through feature transformations and things of that nature, and allows us to rank and explore candidate pipelines rather than having to, spend a sprint or two just fine-tuning a singular model and then doing another model and then comparing and contrasting at the end of the month. This shortens the time frame for exploration and experimentation, so that way we can be productive while staying predictive. So these are some implementations. So of course, there's the Watson Studio AutoAI, which is it sits on a Cloudpack for data, and it's our full suite, our full suite system for solving these kinds of problems, as well as open source libraries such as Lawless, AutoML. There's AutoSKLearn. There's the parse and tree optimizer, MLMox, AutoKeras, and there's others that aren't on this list. So if anyone's interested or knows any that aren't on this list, because this is non-exhaustive, please let us know. So the one we're going to be using for semi-automated data science is an IBM open source toolkit. It's called Lawless. So it works with like grid search, SMAC, things like that, as well as Hyperop. And basically what this is going to do is allow us to set up arbitrary pipelines where we can do hyperparameter optimization and algorithm selection in the same step. And it's pretty low code. So, we can be relatively efficient and spend our time fine tuning and increasing the effectiveness of our models rather than just, deciding what models to use. So it just helps free up some time. This is a reference. And with that being said, are there any questions before we dive into the coding portion?
No questions in the chat currently.
Awesome. With that being said, you can still see my screen, right?
Yes, we can.
All right, awesome. Okay, so as long as the text is large enough for everyone to see, I am just going to show you guys how we would ingest some data and prepare, how would we stage a pipeline and evaluate it using Lawless, so semi-automated data science. So we're going to remove the idea of having to do, by hand feature engineering, as well as the idea of selecting hyperparameter optimization. And then we will also have automated algorithm selection. So the way we're going to do that is we're going to import Lawless, and we're going to import NumPy as, or NumPy as, and import pandas. And then this code will be available on a GitHub in case anyone wants to do it. But we're just going to do our normal read in DataFrame. So read CSV, and then I'm trying to remember where I put this on my computer. Right, and then we can look and make sure that we imported this correctly. So what we're going to do is we're going to drop one of the features, actually, because we know beforehand one of the features is duration. And our goal for this data set is to predict if someone's going to open a term with a bank based off of the information we have at hand. That being said, the information we won't have at hand is the duration of the phone call that the marketing agent has, because we won't have that until the conversation's actually ended. And that actually ends up, knowing what we know now, ends up being the most important feature in the data set, because basically we're able to, linearly determine if the call is less than 2 minutes, the person's most likely not going to open a bank account. And if it's a call longer than 5 minutes, that's a conversation that's normally long enough where they're gathering information to open a bank account. So we're just going to drop that. So that way we can have a little bit more interesting of an example. So we're just going to drop duration, axis equals 1, and then do df.head just to make sure we did it. And it appears that it worked. So now that we've done that, normally we would do some feature engineering and things of that nature, but we're going to make the assumption that our data came in nice and clean. So we will just split it into X and Y, and we'll use sklearn's model selection. So from sklearn model selection, we'll use train test split. And then we're just going to split our X and Y values where we have, our target value, our dependent value, and our independent values. So we're describing where all the columns are not equal to our predicted value. And then we're going to use the dictionary method to convert our yes and no's into ones and zeros. Oops. And then just double check. All right, it appears that it has worked for us. So this should look pretty similar to everyone, what we're doing. And then now what we're going to do is, since we're going to try and take care of feature engineering automatically, we're just going to get our numeric columns and our categorical columns separated. So we're just going to use list comprehension for this. Basically, we're just going to check, like, using NumPy, is it a number? And if it's not a number, it's going to be categorical. So the way we do that is this. So that sets up our numeric columns, and then our cat columns will just be all the columns that aren't in our numeric column. Spot one. And let's just print those for sanity check. All right, cool. It appears to have worked. Our numeric values are here, and our categorical values are here. So now that we have that, we're just going to build out a quick little pipeline. So let's use some sklearn methods. So we're going to import a few preprocessors and a few different models and see which one works best. So from sklearn.preprocessing, import. This no op is just simply like no operator. So it's going to do nothing to the data. And we want to compare that kind of as like our control. So that way we can see, is treating the data the way it comes work better than, actually doing some kind of transformation.
And Austin, just as a spot check, after you're done with this last import line, your second and third imports have sklearn with it.
Oh, good catch.
Hey, Austin,
and then, yes.
There's a question in the chat. What editor are you using?
This is Jupyter Lab. So it's like it's Jupyter Notebook, but you can open text files, multimedia files. There's also like an IBM package that extends this quite a lot. I don't have it turned on right now, but it's called Elira, which has like a pipeline editor and all kinds of fancy jazz to deploy. But yeah, so this is Jupyter Lab, which I think is it's pretty good. I tend to use this or Watson Studio, or if I'm writing like Python files, I'll use Sublime. So we're just going to do like a logistic regression, maybe XGBoost. Yeah, we'll do XGBoost, and then we'll do a decision tree. And then the last and most important thing we need to do is wrap these, because what Lawless is basically built on top of sklearn and has a lot of the underlying functionalities. No module named sk. So what it's going to do is it's going to wrap these, and it's going to allow us to use operators such as like greater than and equal to, or greater than or less than. We'll also be able to use vertical bars to denote a choice, and then we can use like the AND operator as well to concatenate. So it just makes it a little easier to write. And then the other thing is that this will work with any of the sklearn underlying metrics. So if we printed like the sklearn metrics, we could use any of them if we'd like. But I'm just going to take my word for that, because I don't want to spend this whole time just writing code for you guys that isn't helpful for you. So we're going to write out a pipeline that is going to be trainable. And the way we're going to do that is write column transformer as our first step, where our transformers are going to be, well, here, let me make this a little prettier. Our transformers are going to be the number transformer for our numbers. So that will be a normalizer where we use the L1 norm. And we will run that on numeric columns. And then for our cat transform, we will use one hot encoding. And then we will feed that into a logistic regression. Oops. Why does it think that we have too many? Invalid syntax. Did I? Oh, I closed this. Uh-oh. That's not good. Well, maybe we do it a less fancy way. And so this is part of doing live code. So I'm not going to debug this live. So I'll do it a different way. So instead of using column transformers, let's just assume that we did it and that it worked. We will pivot, and we're just going to encode the whole data set. I don't recommend doing this necessarily in real life, but for this, in order for me to make sure I get through this demo with enough time for Will to go, I'm just going to go for it. Why is this not working? Apologies. This should be working. Oh, X. So, okay, so now we have an array and we want to turn it into a data frame. All right, cool. So we've encoded this, and let's make sure that our Y is still what we'd like it to be. All right, awesome. So, cool. Sorry, we had to do just a quick pivot. But with that being said, what we can do is just build out a really simple pipeline. And we will do that real quick. So let's do pipe equals norm or let's do from sklearn pre-processing import standard scalar. All right, so that's our pipeline, and we can visualize it. So our pipeline is we're going to make a choice. So we're going to take in our input, and we're either going to normalize it or do standard scalar. These basically do the same thing, just one is column-centric and one is row-centric. And then we're going to feed it into a logistic regression, a decision tree, and XGBoost. And we will get the correct hyperparameters, or we'll get the optimal hyperparameters, and we'll also select the best algorithm based off that hyperparameter selection. So the way we train it is we have an optimizer where we use Hyperop. So what we're going to do is from lolly.lib.lail import Hyperop. And what Hyperop does is Hyperop's different than grid search CV or SMAC because we don't actually have to specify search space. It's going to do that for us. One caveat is you can reach like non-terminating oscillations with Hyperop. So that is something I would recommend you being aware of. And if that doesn't mean anything to you at this moment, maybe give the paper a read if this is a tool you plan on reading, just so you kind of have an idea of where this should and shouldn't be used. So I feel like that's going to cause a problem. So let's recast this, but this time we use the XN. All right, cool. Just have to make sure all of our shapes line up. So it's running, and it's going to let us know which one's the best. So as we wait for that to finish running, I'm just going to keep writing the rest of the code. So what this is going to do is the summary is going to actually print out what is the optimal pipeline for us. So this can take a little bit of time to run depending on our choices. So here, just for simplicity of time, what I'm going to do is I'm going to stop this, remove XGBoost. Uh-oh. So that should take a lot less time. Yep. XGBoost tends to win, just so you guys know. But not always. Actually, logistic regression gets pretty good results. But as you can see, so the moral of the story is we can summarize our pipeline. And now that we have these arbitrary losses, we could rank them, our candidates. And then we can also get the underlying pipeline and pretty print it out. And so this is our optimal hyperparameters for the logistic regression. For our pre-processing step, we actually use a L1 norm, and then this is our final pipeline. And then if we wanted to evaluate this, it's really similar to sklearn, where we just have our predictions equal train type dot predict x test, and then we can use accuracy score. Okay, and then we get 89.3 accuracy. And then we could change this to like F1 if we wanted to, which is 25% because we get really bad recall because this is a unbalanced data set. With that being said, I hope that was intriguing, and I'm pretty sure I went over time, so I'm gonna let Will take over. But this code it's on a GitHub that I can link to at the end. Sorry about that, Will, for having that happen. And thanks for bearing with me, guys, as we debugged live. But Lawless is a great tool. Check it out. It's ibm.github.com/Lawless. I can drop the link in there, but I'll let Will take it over. So thanks for being patient, Will.
Oh, no, that's okay. Before you head off and we let you escape, I'd like to make sure that I just take one moment to sort of rehash what we actually saw that was AutoML based there, since a lot of that was hand coded, right? You did the encoding yourself, you prepared your data set yourself, but then you passed a set of, I guess, options for model candidates or evaluations, right, into Lawless, and then that was maybe the most automated part of that pipeline in the live coding experience, right?
Yes.
Yeah, so that'll give some useful context for what we'll see on Cloudpack for data. I'll show you guys AutoAI in Watson Studio, and I'm going to share screen so you guys can see what I'm seeing. Austin, could you stop sharing?
Yeah. Apologies.
No worries. Thanks for taking on that Herculean effort of live coding that experience. Okay. Yeah, great. So again, one of the things which I'm going to ground this conversation, I guess, in the data set that we were trying to explore from the beginning, right? This is a bank marketing data set, and we need a way to quickly identify what are some of the important factors for determining whether we can or can't get someone to sign up for a new bank account. And this is a Portuguese marketing data set, which is you guys can pull live right now if you want off of the UC Irvine ML repo, which has a number of other data sets as well, but is one that we've used as sort of an exemplar for a lot of use cases. I'm going to use that banking data set inside of Watson Studio. And what you guys are seeing is Watson Studio on Cloudpack for data. And it's a projects view of a data science environment. So I can add Austin as one of my collaborators on this project. We can work together. We can build out data assets. We can build out notebooks. In the case of what you guys are going to see, I'm going to try a slightly less involved version of AutoML, which is an AutoAI experiment. But I guess the quick overview of, just to confirm that you guys are seeing that same data set that Austin showed. If you click into Cloudpack for data, you can preview the data set, and it'll run what's sort of the equivalent of a DataFrame head, and it's that same information, right? It's the age, the actual account on somebody's or balance on somebody's account. There's some information about the time of the call, and to Austin's point, one of the sort of highly correlated features that we need to preclude when we run the training ourselves is duration. So you'll see me pull that out. When I had imported that data set or the CSV into IBM Cloudpack for data, it imported my index as a column. So I was going to go through the experience of showing you guys how to do a little bit of walkthrough of the data refinery to better select the data that is appropriate for your modeling needs, but we're sort of short on time. So I'll just tell you guys that I ran through a data refinery workflow job, which pulls out that singular column that was a problem. There are a lot of other ways to sort of pre-process the data in data refinery flows. You can group by your content if you need to like aggregate your features into some sort of more informative new feature. So that's all to say that data refinery makes the feature engineering and data pre-processing parts that Austin walked through before fairly intuitive in this like user interface. What I'm going to do for you guys is run an AutoAI experiment, which is our version, IBM sort of opinionated version on AutoML. It's based off of the same Lawless open source library that you guys saw before. So hopefully we're going to enable you guys with running AutoML on an open source as well as sort of IBM opinionated fashion. I'm going to go ahead and create the experiment here and then add the pre-processed data set that you had also seen with Austin. So let me go ahead and do that. What you guys will see in this experiment panel is there are a number of different options for me to like select what I want to classify or like what sort of experiment parameters I want to run. So Austin chose a number of different models that were candidates for giving us the best classifier, whether someone will or won't sign up for our new telemarketing account. Those are also options for us in the prediction. I'm going to just quickly unselect the duration, which is too highly correlated for our use case. But you can see you can optimize your metric for any number of, or you can optimize your pipeline rather for any number of metrics. I'm going to choose F1 because to Austin's point, this is an imbalanced data set. So we have a lot fewer people who have selected to sign up than who haven't. So that imbalance means that we really want to use the harmonic mean. There are a number of different algorithms in the same way that Austin showed that you can choose here. And you can also determine the number of pipelines that you can have AutoAI select for you. But as part of this AutoML experience here, right, we're trying to simplify the automated feature engineering. So AutoAI will go through and evaluate my features for possible combinations and or like repurposing to hopefully gather the most signal possible. We will do hyperparameter optimization, and we'll also do automated model selection. And the output from this experiment will be a number of candidate pipelines. And it's a great way for us to look into them, sort of select which ones maybe seem like they are the best candidates possible. And by doing this early on in my workflow, I have the chance to be building out rapid prototypes, right? Building out prototype models that are potential candidates for deployment later. And then I can save those models that have been trained. And in some cases, you'll see in the open source, like community citizen data scientist role, you'll see those saved as like pickle files. In this case, I would save the trained model as a model to be deployed to Watson Machine Learning, which is, again, another service from IBM, which hosts and/or like gateways the deployed models that you would train in Watson Studio on IBM's Cloudpack for data. But that what seems like an added step is really a way to simplify the handover from model training to model deployment. And you can take that sort of rapidly prototyped example that you've identified here in AutoAI and quickly move it into a deployed instance or context so that people can start to do like canary testing on it, right? You can A/B test. You could theoretically add this to multi-arm bandit for multiple models to be consumed against. So there's a lot of power and/or capacity from AutoAI to actually quickly make advances in your predictive modeling efforts. So I just walked through reviewing that data. You kind of briefly saw that I split that data into a training and holdout set. You're seeing that sort of visualized here. I've chosen specific percentages. You can mess around with those in your experimental settings. I chose which features I wanted to be included in the candidate evaluation for automated feature engineering, for model training, and then to be submitted to these pipelines. And then I chose which models to evaluate in my pipeline development so that I know which are possibly the best or worst classifiers. You'll see that the pipelines will start to pop up here occasionally, and they've been optimized for my F1 score, which was the metric that I selected. But I'm going to pause here while this still trains and review what I'm hoping are questions in chat, because that was a lot of information that I tried to cover in a very brief time. And then just, I will take this one step further to actually explore into the pipeline once these are done training. So you don't have to have answers quite yet. Okay, cool. No obvious questions here. So give me one more second to let this thing run, or we're running out of time. So I guess I'll just explore what kind of information is available in this AutoML capacity.
Will, there's one question.
Yes, sir.
In the QA panel. So JR
cool.
Asis, I hope that's how it pronounces, asks how many machines is this running on in parallel for the grid search?
Yeah, so one of the beauties of Cloudpack for data is that I don't have to be, that's opaque to me, right? I don't have to be aware of what it's consuming behind me or what's consuming behind this interface, but that's what you have available to you to train models in parallel is dependent upon your the resources that you've signed up for, right? So like I have a standard access as an IBM employee. Your free resources are slightly diminished as compared to a standard access. And then obviously there's an enterprise level access as well. That frees up more capacity for your training. Great question. So let me just quickly evaluate the information in each one of these pipelines so that you guys can sort of see what one of the outputs from this is, because I know that we're running up on time. And I want to make sure that we have more of an open floor for questions to both me and Austin. So we optimized again for F1 measure because the harmonic mean of the precision recall will be maybe more reflective of an imbalanced data set than say accuracy might be. We can take a look though at this pipeline, this candidate pipeline across the holdout and cross validation for not just F1, but also accuracy and precision and recall, as you would sort of expect. If you had maybe not preconceived that this was an imbalanced data set and or understood that going into it and needed to view how many actual, what the actual imbalance or class balance looked like, the confusion matrix is a great way to see what the distribution of your positive classes and negative classes look like. And then if there had been automated feature engineering as a part of this AutoML pipeline, you would see in this model viewer portion below here also the newly created features. And it's probably the case that in some of the other pipelines, you'll see that, since that's one of the features included. But here at the very least, you can see which are the features that are rated as important for predicting our final outcome, whether someone did or did not actually sign up for a new account. And it's split up by rank, right? Or it's listed by rank. So when someone reached out, their method of contact, and then a host of other features. And let me see which other of these model pipelines have finished. Yeah, I'm going to go into this this pipeline, which wasn't the first ranked one, just so that you can see some of the feature transformations that are done in an automated fashion. So Austin had done some feature cleansing, some data cleansing on his own, right? But he didn't do any of the combinations or experimentation exploration to see which interactions between those features might give us more signal. This is an example of some of the types of feature transformations that AutoAI explores to give you a better sense of what is potentially more or less predictive in, will gather you more or less signal in your predictions. So it's automated what looks like 10 to 15 new features that it says it believes are going to be useful for us. And we can see that they actually are less indicative of whether someone will or won't have signed up for a new account than our original feature set. And that's useful information for us to have, right? This pipeline also went through some automated hyperparameter optimization. But I think that at the very, that's kind of a lot of information for us to go into here with the last 30 seconds. So I just want to show you as the last view that there is the option to sort of compare multiple pipelines. So if this had trained a whole host of pipelines, you can see on the cross-validated set versus the holdout set of data, the competing level of, or competing metrics that we had trained this model for, right? So you can see its precision or its recall, and use case by use case might select a different set of pipelines, right? Based off your business problem, you might have need to optimize for one metric over the other. And the last thing I'll say with my last couple of seconds before hopefully answering a question or two is that if you wanted to play around with AutoAI on your own, but you maybe didn't want to sign up for an IBM Cloud account and pay for compute, there are easy to use AutoAI guided tours so that you guys can click through, check out some of the features on your own, check out what it would look like to model using AutoAI, and even get a sense of what deploying that model might look like. And I've just run into time, so I appreciate everybody's patience and apologize for anybody that I ran too long for. And I will go ahead and stop sharing. I'll put that link for this tour into chat, and then I'll let you guys maybe ask a question or two before we give the mic back to Bill.
Yeah, I think we're doing good. I think we can go over a little bit. They may have actually planned for a little bit more than 60 minutes. So yeah, I think we have a couple of questions.
Oh, great.
Q&A panel, and also one question in the chat. I'm not sure if you already answered any of them. That's
okay. Yeah. So let's see. Yeah. So Michelle asked, for the free version, there's approximately how long would the same grid search take to process? Are there trial periods for the paid services? Yeah. So there are trial periods, and IBM Cloud specifically makes that trial process nice and simplistic. The data set that I chose was the bank marketing one that we chose. I chose the smallest version of, so it should easily be able to train on a free instance of IBM Watson Studio, or the light instance as it's called, rather. You have, I think, 50 or 60 capacity unit hours, which are sort of an obscure term for how much compute time you're really leveraging from the IBM Cloud side. but that is absolutely sufficient for training on that data set that we had selected before, or that I had placed in the chat before. So there's a link to that data set in the Zoom chat. Okay. Joel says it's 3 a.m. for him. Joel, thanks for staying on so late. JR said, oh, sure, JR. Thank you for hanging in there and checking out the performance of those models. And then Tim, was there another request? Oh, Raphael, I apologize if I'm mispronouncing that. You asked, can you manipulate a pipeline created changing its hyperparameters? Yeah, so one of the things that you can do is export the trained models and pipelines into a notebook, which is a new feature in Watson Studio. And then there are a great variety of things that you can do to play around with the trained models and or pipelines themselves. And that really frees you up to manipulate the pipelines as you need or as appropriate for your business case. And then I think that was it.
I see one more. Did you already answer that? Can we use a custom model algorithm that we implemented ourselves? Is from Tanyi.
Oh, I missed that. So sorry. Can you implement?
Just in all.
Yeah. So okay, I'm not. I don't see that question, but just to speak to using custom modeling yourself. So the Jupyter Lab interface that you saw before with Austin is a part of the Jupyter ecosystem, and Jupyter notebooks are an open source version that don't have that lab, that same lab tabular format, but have the executable cells in that same fashion. And Watson Studio has the ability to work with Python kernels or Scala kernels or R kernels in that same Jupyter Notebook interface inside that project view. So you could add a new notebook, do the automated model training yourself, or not do the automated, do the model training yourself rather, and sort of customize it to your own degree, whatever sort of fashion is appropriate for you. But it doesn't depend on, AutoAI wouldn't depend on anything pulled from that notebook, right? We were going through like very guided experience of AutoAI.
Will, could I say something?
Yes, please.
I'm unsure. So I'm unsure how to pronounce this name. I think it's Tiny. But yeah. So I think this question you're asking, the custom models, and you can do that in Lawless. So there's the Lawless like wrap operators function you saw me do at the end, which is like kind of like a decorator. There's an associated there's another associated wrapper where basically you could, like, if you had some kind of function that like squares something, subtracts the minimum, and then multiplies it by 100. You can wrap that in Lawless and put that in your pipeline, whether that's a feature transformation or an actual like algorithm for classification or regression. You can wrap it. The important thing to denote is Lawless has a schema implied for the data set when it's passed through a pipeline, so it denotes the types. You're going to have to make sure that whatever custom algorithm you have is an agreeable format. So if your data set strings, it has to be able to accept strings. That part can be a little bit non-trivial just because Python's a dynamic language. That being said, it is doable. So I'd look into Lawless. And then on the AutoAI side, when you, like Will was saying, when you generate those notebooks, that's when you have the ability to further customize things or fine tune your hyperparameters if you're interested in that. So I just want to add on to that, Will.
No, I appreciate it. Thank you for stepping in there.
And then we got a couple more good ones. I mean, first on pricing and do we offer student accounts? And then the next one would be, does that mean that, this is from Raphael, does it mean that the data scientist role will be unnecessary with Watson? That's a good one.
Yeah, so I think it was Milan who was asking about student accounts. Watson Studio Lite are their free accounts, absolutely. And it's definitely not the case that, in reference to the second question, it's definitely not the case that data scientists are a moot role at this point. It's more that AutoAI is an additive tool set for any data scientist who needs to start training models sort of simply and quickly, right? That prototyping experience is a good way for you to identify whether there even is signal in your data to potentially model against the hypothesis that you or your business owner may have. That prototyping experience lowers your time to actually proving those concepts out. But a data scientist still has to do the hypothesis testing, the feature engineering, the translation of expertise into your data set. Those are really critical capacities that expertise from a data scientist is not soon to be replaced by really any toolkit. This just shortens the process overall.
Great, thank you.
All right, well, thank you so much, guys, for listening to Austin and I. I think you hopefully have all the links that you need. If you want to reach out to us, feel free to on LinkedIn or Twitter. I think maybe one of the last things from us was making sure that we handed this back over to you, Bill. So
yeah, just one more thing. So that I think a couple of questions were about, are you going to make the slides or any of the code stuff available? I think we can coordinate with Bill and you can maybe send it out in the follow-up email. Does that make sense?